Hi and welcome. I hope you've been following the videos and you know that all the programs I discuss here have links in the description below, which you could open, practice, and understand the topic better without having to download the software. And do subscribe if you haven't done so already. A function is a named block of code that can be used to perform a specific task. As programs grow in size, functions can help create smaller, manageable parts that can be called whenever required. Therefore, functions provide better modularity and reusability. So how do we create user-defined functions? We start with the keyword def, followed by the function name and parentheses, and then it ends with a colon. Any parameters or arguments are placed within the parentheses, and the first statement of the function can be a doc string, which basically explains a little bit about the function. The statement return with an expression exits the function and optionally passes back a value from the expression to the caller. This is the syntax of a user-defined function where it starts with the keyword def, followed by the function name and parameters which are written within parentheses, followed by a colon. The block of code in the function suite could start with a doc string and end with a return statement. Defining a function only gives it a name, specifies the parameters that are to be included in the function, and structures the blocks of code. Once the function is defined, you can execute it by calling it. That is, by writing the name of the function and passing the values to the parameters. Let's look at this with an example. We start with user-defined functions in Python. Use the keyword def and the name of the function is print string, to which we have passed a single parameter str1. This function prints the length of a string. This is the doc string. And we use a variable msg to store the length of the string. And here, since we are going to concatenate the length with this string, we are going to use str to convert it to a string and return msg. We'll call the function print string and pass calling the function, this function first time, and we are storing it in variable x, which we'll print. You can print it straight away also by saying print string, calling this function second time, and output simply with the print statement. Another function is test func, which we pass a parameter, single parameter z. This function is going to find the increment the number by 3. So z plus is equal to 3, return z. If we give a print statement after the return statement, it will not be executed. And we'll call this function like a variable inside the print statement. We have another function new underscore func, to which we pass num as a parameter. This is going to double the value of the number passed. And we are going to return num, and we use the print statement again like a variable. We are going to pass the function to this, make the number double, num underscore func, to which we pass 10. When we execute this program, we'll see that when we call print string function for the first time, we pass the argument calling this function for the first time to the parameter str1, and it outputs the length of the string is 32. We can call it another time, and this time we are passing the parameter calling this function second time, and we get the output. The length of the string is 33. We get the output for test func When we pass the value 3, the output is 6. Notice that it has not incremented 6 by 5, which was written after the return statement. Hence, anything written after the return statement is not going to get executed. The third function we have here is going to double the value of 10. So here it says making the number double 20. A return statement is used to end the execution of the function call and return the result, that is the value of the expression following the return keyword, to the caller. If the return statement is without any expression, then the special value none is returned. We look at return statements in functions. We start with the function test underscore prime, to which we're going to pass a single parameter n. We'll check if n is 1, it is not a prime. If it is 2, it's a prime. And for all other numbers, we're going to check the number by dividing it by numbers from 2 to n minus 1. And if any of the remainders is 0, it's not a prime. Otherwise, it's a prime. We'll run this function multiple times, and we see that for 43, it outputs 43 is a prime. And for 34, it outputs 34 is not a prime. If we change this to, say, 1, and we change this to 2, we'll see that when we execute this, we'll get 1 is not a prime and 2 is a prime. So even though we have multiple return statements, because of the if, elif, else construct, only one return statement will follow. Now we see another function where we've used the print string function with the parameter str1. In this case, we've used a print statement within the function, and in the return statement, we have no expression output. Now, when we run this function or execute it, we'll see that it outputs the length of the string is 12. However, it also outputs none because of the return statement having no expression. We'll now look at an important concept called function scope. Functions provide a nested namespace, also called a scope, which localizes the names they use, such that names inside the function won't clash with those outside the function. Python uses the location of the name assignment or definition to associate it with a particular scope. So where you assign or define a name in your code determines the scope or visibility of that name. Let's look at various scopes of variables that are available in Python. There's built-in, global, local, and enclosed. The Python scope is generally presented using a rule known as the LEGB rule. L stands for local, E for enclosing, G for global, and B for built-in. Local scope is the code block or body of any Python function, and the Python scope contains the names that you define within a function. Enclosing scope is a special scope that only exists for nested functions. This scope contains the names that you define in the enclosing function, the names that are visible from the code of the inner and enclosing function. The global scope is a topmost scope, and in Python program, script, or module, it is visible from everywhere in your code. Now, built-in scope is a special scope that's created or loaded whenever you run a script or open an interactive session. Now, this scope contains names such as keywords, functions, exceptions, and other attributes that are inbuilt. Let us look at variable scope in functions. We start with a global variable result, which has value 0. We also have another variable result, which has local scope because it's inside the function check underscore sum, which has these two parameters. And the sum of these two parameters is stored in this variable, which is then returned. When we call this function, pass two values to it, it will return the value of the local variable result, 50 in the first case and 60 in the second case. When we output result outside the function, we'll see that it gives the global value 0. We have another variable x to which we assign the value 2, and here it has global scope. We have the same variable x to which we assign value 300 inside a function called outer underscore function, which has local scope. We have a nested function called inner underscore function, in which we give the value of x as 50, so it has enclosed scope. Now, we've also declared another variable y, and we've used the keyword global here. So in this case, the variable y will have scope global. Now, if we execute the outer underscore function, we'll see that it outputs the local value of x, that is 300, but it also calls the inner function and it returns the enclosed value of x, that is 50. If we print the value of x outside the function, we'll see that the value is 2, which is the global value. And if we try to output the value of y, it will give us an output 500. Information can be passed into functions as parameters or arguments, and they're specified after the function name inside the parentheses. You can add as many parameters as you want, each separated with a comma. We're going to look at 4 of these: the positional or required parameters, keyword parameters, default parameters, and variable length parameters. Positional or required parameters are passed to a function in correct positional order. Here, the number of parameters in the function call should match exactly with the function definition, and by default, parameters are positional. We start with positional parameters or arguments. We look at an example where we have a function called remainder underscore fn, which has 2 formal parameters. The parameters which are given when we define a function are called formal parameters, and the parameters which we give when we call the function are called actual parameters or arguments. Now, in this function, the return statement will return the remainder of x divided by y, which are the 2 parameters. And if we do not pass any parameter here, it will give us an error. Now, in case we pass one parameter, it will still give us an error. It's only when we pass 2 parameters, we give the output as 1, which is the remainder of 5 divided by 2. In this case, the second example is a function info, which has 2 formal parameters, name and age. And we have this statement which says if age greater than 18, then print name and age. And we call this function. And in this case, we don't have a return statement. We just have a print statement. We call the function, pass the value of the name, that is a string, and then we pass the age, which is an int. Now, in case we execute this, we are getting, hello Naina, you are 19. But in case I change the positions of these 2 parameters and put the age first, it will give us an error. Now, it says not supported between instances of str and int. So in this case, it is reading the integer as a string and the string as an integer, and that's giving us an error. Now, we can solve this by using something called the keyword argument. When you use keyword arguments in a function call, the arguments are identified by the parameter name. This allows you to place them out of order because the Python interpreter is able to use the keywords or parameter names provided to match the values with parameters. So we look at keyword arguments in functions, and we are looking at the same example of the function info, which has 2 formal parameters, name and age. In this case, when we call the function and pass the actual parameters to it, we use the name of the parameter in the formal parameters and assign it a value. Now, in this case, if we interchange the positions of that parameter, it will not matter because it will sort it out using the keyword that is given. Now, in this case, we have print info is the name of the function. It has 3 parameters, formal parameters F name, L name, and age. And again, we check if age is greater than 18, then it's going to print all these. Now, in this case, again, we have changed the position of these formal parameters, but since we use the name of the variable and assign the values to it, it's going to print the output. Sometimes a parameter is assigned a value in the function definition. A default argument is an argument that assumes a default value if the value is not provided in the function call for that argument. We look at default arguments in functions where we have print info, the name of the function that we were using in earlier. In this case, we've given a default value to age. Now, in case the user does not pass the value for the variable or the formal parameter age, then in that case, it will not give an error. Instead, it will use the default value that was given to the formal parameter and give an output. You may sometimes need to process a function for more arguments than you specified while defining the function. These arguments are called variable length arguments, and an asterisk is placed before the argument. The variable length argument is always given after all other arguments are given in the parentheses. That means it should always be the last argument in the parentheses. We now look at the variable length parameters where we can use an asterisk in front of a formal parameter, and that can be used as a variable length parameter. Now we look at the example of a function called print code, which has two formal parameters, year and list1. Now in this case, when we say first year, that's going to be passed to the variable year, and 101 is the value we pass to list1. When we call this function the second time, we're going to pass the value second year, and now we pass two parameters for list1 formal parameter. And in the third case, when we call this function, we pass three values for the formal parameter list1. We have seen various types of parameters or arguments being passed to functions. We shall now see some mutable and immutable data objects as parameters. We start with lists, which are mutable, so they can be changed inside the function. Then we look at tuples, which are immutable. We now look at an example for immutable and mutable parameters. We're going to take a function change underscore list, pass a list to that, and we're going to change the number at index 0. We're also going to append something to this list, and we'll return that list. In case of tuples, we have a function called tuple underscore change, and we'll try to change the element at index 0 in this case. And we'll see that when we execute this, the first function will return a list which has been changed both at index 0, and it has also appended a new element to the list. However, in case of the tuple, it has given us an error. The tuple object does not support item assignment. We're going to use a math library in a function in Python. We'll start by importing the math module. We'll define a function sector area to which we pass two variables, first the radius, then the angle, and we're going to check whether this angle is greater than 360, and we give an error for that. Otherwise, it should give us the area of the sector using math.py multiplied by radius raised to power 2 and multiplied by the angle upon 360. Now, if we pass the value of the radius as 7 and the angle measure 90, we execute this function, we'll get the sector area as an output. We're going to look at the usage of string functions within a function. We'll define count underscore case as a function and pass a string to it. We also define a variable D, which is a dictionary to keep a count of upper and lowercase characters. We have a loop for C in S, which will look at each character in the string. And we'll use is upper and is lower functions to check whether the characters are upper or lowercase. Now, in case it's an uppercase character, it will add to the value of the key uppercase in the dictionary. Otherwise, it will add it to the key lowercase in the dictionary. And in case it's anything else, like a number or a special character, it will go to the else statement and pass that. Now it will output the uppercase characters and the lowercase characters as an output from the function. So when we execute this function and use this string, we'll see that it gives us the number of uppercase characters as 6 and the number of lowercase characters are 16. So that was a little bit about functions. You can go ahead and click on the links and see the programs I discussed, and I hope to see you very soon.